What's up, everybody? I wanted to start doing some videos here. I want to start going over some LeetCode problems, but do them in Solidity. Obviously, not all the LeetCode problems will transfer over to Solidity perfectly, but I feel like it's kind of cool to do some of these here because by default, LeetCode doesn't offer Solidity as one of their solution sets here. So the first problem we're going to deal with here is probably pretty simple, but of course, as hopefully you guys are learning a little something here too, I'm learning something too because as I explain my thought process, I feel like it helps me learn too, so it's kind of like a two-way street. So first off from here, let's read through the problem, and then we'll talk about in Remix. So very simple from here, we're going to add two integers together. We're given two numbers, and we're going to add them together, and we're going to return the result. The constraints are going to be negative 100 to positive 100 from here, so we do have to keep in mind negative numbers. So if we go back to Remix, we have SPDX license identifier, we have pragma solidity greater than 0.8.4. Let's go ahead and set up the contract. Contract add two integers. Cool. So that's pretty self-explanatory from there. I mean, if it's not, we just set up a contract. These curly braces, everything within the contract goes within here, okay? So let's go ahead and make a function. We're going to call this function sum because that's kind of how they have it set up here. And we're going to take in some arguments here, but we're going to talk about them more in a second. We're going to make this public. If you're not familiar with the keyword public, public means that anybody or anything can call this function. Other contracts can call it. People outside the actual contract itself can call it. For lack of better terms, it's kind of open per se. And then, of course, we have to return the result here. So we're going to say returns. Now, you may see a lot of times with Solidity and with smart contracts, it's uint 256 keyword. And although that works a lot of times, keep in mind that uint stands for unsigned integer. So this doesn't take into account negative numbers. So if I say something like uint 256 and we call it a and we set this equal to -5, we're going to run into an error. It's going to say, hey, wait a minute, you're not allowed to declare negative numbers for uints. You have to make that just an int. So let's remove the u, and now it's looking better. Now we do have to return, so let's go ahead and say return a, so we'll return that -5 word. So now we don't have a red error anymore, but now we have this kind of orange error from here, more of a warning. Now it's saying we can restrict the state mutability can be restricted to pure. Basically a pure and a view, that makes it so that we don't, not makes it, but a pure and a view is basically showing that we don't modify the state of the blockchain at all. We're not modifying the data on this blockchain. If we had a number and then we had a function to change that number living on the smart contract, that would cost some gas fees. Since it's not changing anything here, it doesn't really cost any gas fees. So we have that keyword pure to kind of help us out from there. So this is looking halfway decent. We have to take in some numbers here. Let's say int 256, let's call it num1, int 256, num2, and now it's giving us some warnings because we're not using those parameters. So let's go ahead and change this. We're going to say num1 plus num2. And now we can change this keyword here just to make it a little more specific. Result. So now this is looking pretty good from here. We're taking in two numbers. They can either be positive or negative. It's a pure, it's public, and it's going to return that number back here. Compile, mine's an auto-compiled. And let's go ahead and deploy this. So we didn't run into any issues with deploying the contracts. If we run these two test cases that they give us, 12 and 5, we get 17 back. If we run -10 and 4, we should get -6 back. And we run it, we get -6 back. So it looks like this is working. This looks like this would be an acceptable solution. But I could optimize this a little bit further from here. This 256 keyword, what I could do is I could actually restrict this down to only 8 bits. If you're not familiar with this 256, what this number represents, that refers to the number of bits that this integer takes up in the EVM. So an 8-bit number, if we're talking about an unsigned 8-bit number, we have a minimum, or an unsigned, which means a non-negative number, the maximum value would be 255. Since we're talking about just an integer, it could be negative, the minimum value is going to be -128, and the maximum value is going to be 127 from there. So that satisfies the requirement of this constraint from here. So we can optimize a little further, and this way it's not taking up as much space in the EVM. Now, we do run into a little bit of an issue from here. If we try to change this to an 8, remember that the minimum value for both these numbers could be -100 or +100. So we have 100 and 100. Let's go ahead and change that from there. and we add them together, now we're overflowing this number from here. So this one, we don't want this to be an 8-bit. This time we want it to be a 16-bit. 16-bit from there. Let's go ahead and remove this old contract just to make sure this is still working. And let's go ahead and deploy this. Let's go ahead and try it out. What was the, it was 12 and 5, I believe. 12 and 5. Call. Still working. Negative 10 and 4. Go ahead and call that. And that's still working from there. So it looks like we have our solution. Now, one more thing that I want to try here is just kind of removing this middleman. If I just take these two numbers from here, copy that, paste that, and remove this middleman from there, we can try this one more time. We can hit deploy. Makes it a little more readable if we try our numbers out. 15 and 5, or 12 and 5, whatever it was, still works. Negative 10 and 4, still working from there. Looking good. So if you guys learned something from here, be sure to give me a thumbs up, comment down below, and subscribe. This code will be on GitHub, although it's very simple. And hopefully you learned something here, and hopefully you guys enjoyed the video. Appreciate your time, guys, and I hope you guys have a great day.